Hello, everybody. Welcome back. Hope you guys are doing great. We'll be starting in just a few minutes, 2 minutes. Feel free to say hello or anything else. Always good to see you guys here at the meeting. Hi there, Janie, Arlene, John, Rev, Isaiah, and a good morning to everybody. Samir and Melanie, good to see everybody here. Hey, Valeria. Okay. All right, guys. Well, it's mostly 11:30 now, so good morning, everybody. Good to see you guys here in the chat. I thought today the first thing I will do is just kind of go over the homework with everyone. I'm going to send off also an answer key for the third homework, but I just guess while we're all here together watching, and just to capture it on video for posterity, for you to reflect on later, I would like to just go over the homework problems one time. So I'm going to pull up homework number 3, and I'm going to just do the dual platform situation. So I'm going to share our Zoom link here, and then I'll start going over the problems when we all display it here. So just 1 second. Okay. Hey, Leo, Marissa, everybody there. Okay, so what you see then is the link, as usual, for the Zoom element of the meeting. Go ahead and get that going, and then I'll be right there with you. Okay. All right, here we are. Welcome to the Zoom. Let me just pull up the screen share function. Okay, so now you can see that. And let me get the chat to the right over here. Can anyone just type something out in the chat? Make sure everyone's good and we can hear. Okay, perfect. So can we all see the problem set displayed here? Yeah? Hopefully so. Let me actually kind of fix this a little bit so it's more to the left. Okay, great. So we're now looking at the problems from homework number 3. Let me just start at the top. Okay, so the first 4 questions on this homework were just translation exercises. And we've done those many times so far, so hopefully the process is getting a little more familiar to you. Let's see how you would have answered number 1. Okay, so this is homework 3, and for problem 1. Let's see, anybody can tell me. How would you have answered this problem? Or let's get the symbolization going first of all. So we need some sentence letters in order to translate this into logic. So let's throw out what you think could be a letter and what sentence could it stand for. That could be our starting point right here. Talking about question 1 in the problems on homework 3. To you then, please, just let me know. One and all. D for the dictator will be assassinated, okay. Okay. C, the dictator's countrymen rebel. Okay. C for countrymen, okay. I, CIA intervenes. Okay. Okay, so D, C, I, these are the sentence letters. So using these letters, how would we transcribe the sentence that's written there? Using the connectives and the letters themselves. It says, dictator will be assassinated only if his countrymen rebel or the CIA intervenes. So we're now just needing to put those parts together and state the sentence in logic. So what would it look like? D arrow parentheses C wedge I. Exactly, correct, yes. Just so it's clearly a parenthesis rather than a letter C there. And there you go. That's our answer for the problem number 1. When you see the phrase only if, as it says here in this sentence, the information that is placed on the right side, the right hand of the phrase only if, is the consequent of the conditional, meaning the part that is on the right side of the tail of the arrow. So dictator will be assassinated, D, only if, and then this stuff is on the other side, only if either the countrymen rebel or the CIA intervenes. So that would be 10 points for problem 1. No questions. If at any point as we go through, if you had a question or clarification that you're looking for, just let me know and we will go right over it. But for now, anyways, that's problem 1. Okay. So let's now take a look at problem 2 and help me again. So it says all this stuff. Milo can make money on his egg transactions if, but only if, he can sell them for 3 times what he pays for them, and he doesn't have to bribe more than 3 generals for his use of Army aircraft. Okay, so I just would like to see what you think about the sentence letters, first of all, for this one. What to start with, and then you can just tell me here in our chat. Go right ahead. Don't be shy. M, Milo can make money on his egg transactions. Okay, perfect. So this is problem 2. M stands for Milo can make money on his egg transactions. Okay. All right, so there's M. That's part of it. That's for sure needed. Now you say, Brenna, S. Milo can sell his eggs for 3 times what he paid for them. Okay. Okay. All right, so letter S for selling those eggs at 3 times the rate he paid. And then we still need a little bit more. So what could be the last thing here? B, Milo bribes more, or it shall say has to bribe more than 3 generals for his use of Army aircraft. Okay, and so we're going with B for bribe, I guess. More than 3 generals. For his use of Army aircraft. Okay. MSB. All right, so we've got our sentence letters. Now we just have to use these together with the connectives to correctly translate this sentence. So let's see what you think. Lily, M double arrow S, so M double arrow parentheses S and not B, close parentheses. Yes. So what that says is that Milo can make his money on his egg transactions, M, if but only if, that's if and only if, that's the biconditional, which can be the double arrow or the triple bar. And then the statement that is the other element of the biconditional is that he can sell the eggs for 3 times what he pays, and he does not have to bribe more than 3 generals. So tilde precedes the letter B. Would it be wrong if I forgot to put has to bribe? No, not necessarily. I mean, it's tech bribe, but that he has to, like it's a requirement or whatever. But I would be willing to overlook that. So yeah, let me just put it here as it's shown in the chat. M, double arrow, parentheses S, and not E. All right, Milo can make money on his egg transactions if, but only if, both he can sell the eggs for 3 times what he paid and not the case that he has to bribe more than 3 generals for the use of army aircraft. So this here would be question 2. Okay, nice. The exact wording of some of these examples, I have colleagues, right? And in this case, it's taken from an example that a different colleague gave. So I have no idea at all what is the discussion that it is making about a person named Milo, eggs. That, of course, isn't really important, but I just mentioned that because you might have thought, what is this professor doing with these weird statements about eggs? Well, it is weird, yes, but I didn't create it, so anyway. All right. So then it's number 3, okay? The third one. This one is like I don't know, it's a freebie, I thought. It's kind of like a deceptively easy question. But let's try and do it. So it says, as we all know, everyone has a price, but Milo's price is too high to pay. So what do you think? E, everyone has a price. Good. So this is number 3. Everyone has a price. And also, we've got to have another letter. Which one? For what statement? M, Milo's price is too high to pay. Evan has a price. Milo's price is too high to pay. So, pretty simple. What's the full translation now? For our third question. E and M, yes. That's all. So that's the answer of number 3. The statement or the phrase, as we all know, is not its own individual statement. It's just claiming, hey, this sentence that I'm affirming is something I know, but that does not change the logical content of the sentence. So the sentence letter just abbreviates for everyone has a price. M, Milo's is too high to pay. So if everyone has a price, but Milo's is too high to pay, the word but is a conjunction word. So we just conjoin these 2 statements into one big conjunction, E and M. Okay, so next it's question number 4. So let's see what we can do with number 4 now. It's saying that although neither of the 2 candidates, Smith and Jones, is worthy of holding public office, one of them will be elected. Okay, so let's see what you can tell me about the different statements here. S, Smith is worthy of holding public office. Okay, J, Jones is worthy of holding public office. Okay, so we've got those. E, Smith will be elected. And finally, W, Jones will be elected. Okay, good. All right, so that's all we need in terms of sentence letters. So now just putting these things together. Although neither is worthy of holding the public office, one of them will be elected. So Jessica, you have both not the case that parentheses S or J, and also E or W. Correct, yes, exactly. So neither of the two candidates is worthy of holding public office. That is tilde negating a whole either statement. So not either S or J. This says not either Smith or Jones is worthy of holding public office. Neither one. But, right, so it continues there. Well, although neither of the candidates is worthy of being elected, and the word although is a conjunction word, as you would see on page, I think, 59 of the book, where it lists all the English words that can be translated by means of these connectives. So although is a conjunction word, it means and. So although neither is worthy, one will be elected. One of them will be elected means either E or W. It will either be the case that Smith is elected, or it will be the case that Jones. So either or. And that is our full expression written out there. Okay, so that would be the answer of number 4. Now we've seen the correct answers for 4 of the problems. That's 40 of the 100 points possible. So we're going to look now at the next few questions where the topic changes a bit from just translation to now truth table. Okay, so it says in the instructions, use the truth table method to answer the following questions. In each case, construct a full table unless instructed otherwise. So it's saying here to just give a full table for these two. So let's do number 5. It says, is this sentence logically true, logically false, or logically indeterminate? So we must create a truth table to figure this out. The truth table starts with a cross, and from there we write the statement or statements that we wish to analyze on the top right. So in this case, it's a single sentence, and you see it written there. It says M or not M, if and only if not N, then N. Okay, and I'm departing from the arrow just for the sake of a change up, but as you should know, this could be the double arrow or this could be the single arrow. That's an alternative symbolization for it. Now, there's a main connective in the sentence. Which one would it be? To anybody that knows this, yes, loveth, the double arrow. In other words, the triple bar right here. Okay, so now on the top left, we always have to list the letters that occur in the formula, and we have to do them alphabetically. So this should say what? MN, LMNOP, MN. Okay, so with 2 sentence letters, there must be a total of, who knows this fact? How many rows? 4, correct. Okay, so the pattern is that the leftmost row has the top half T and the lower half F. So where there are 4, that means 2 by 2. Now as we slide to the next column, the rate of alternating between T's and F's just doubles. So instead of it being 2 by 2 alternation, it is 1 by 1. T, F, T, F. And then we simply repeat the pattern displayed here underneath every occurrence of the relevant letter. So under where we see M, T, T, F, F. Under each case of N, T, F, T, F. Okay, so as we should know, we save the main connective for the very last. So this is going to remain blank for the moment, but we have to then do the other 2 sides first. So let's do this one. This is a disjunction. We have a tilde on the left of this letter M. So what that does, as it's a negation, is it simply reverses these values. So what we'll see is F, F, T, T. Now this is the disjunction column, okay? Now what we are going to look at is what's on the left under M and what's on the right under the tilde. If we see on either side the letter T, then we will mark T in the disjunction column, because when one of the 2 disjuncts at least is true, that means the whole disjunction is true. So what's the value in each of these 4 rows, starting at the top? Blank, 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 blank. Just please list for me the ordering of T's and F's. Okay, it's all T's, correct. All right, now the left side's all complete. We next have to do this part. Now, if all we were doing was just this one expression, this would be its main connective. So like that's the way you know that you have to say that for last. Therefore, we have to start with the tilde on the left of n. And just as with the tilde always, it reverses these values of its immediate component. So ft, ft. Now we'll fill in this side, looking at the side of tilde and the right side of t. So what are the four values that should be shown in this downward vertical column, starting at the top? TF, TF. Okay, good. We've reached the final stage of the truth table, where we fill in the main connective column. And what we're now looking for is the information of the wedge column and the information of the horseshoe column here. So the rule for biconditional is that they must share the same value for this to receive t. And if they differ, like one says t, one says f, then in that case, we write f here. So yeah, first case, first blank space, what should this say? T, yes. Why? Because this is t, and so is that, so those match. In this case here, what's the case in this space? Row 2, f, yes. And that is because t and f over here do not match. So that leaves us with f. Third space in the column, row 3, t, yes, good. Because that's, again, it's t matching t, that's true. Finally, in the fourth final blank space, row 4, we see f. And that's because here and here, that's t, that's f, those don't match. So circle the column underneath the main connective. And now we finished the work, but we have one question left. And the question is this sentence logically true, logically false, or is it logically indeterminate? What's the answer? Having this circle column gives us the answer. It is logically indeterminate. That is a logically indeterminate sentence because depending on the truth values of the different sentence letters that occur within it, it could be true, or in another possible truth value assignment in another possible world, it could be false. Since we see T's and F's both, that means it's logically indeterminate. Okay, so here's our correct answer for question 5. All right then, so we're just going to keep moving along and do the rest. So next it's number 6. This set of sentences that you see there. So to create the table, again, we have a cross, and we just have to write each sentence that occurs in the set on this top right part. So we have tilde B, not B. D, if and only if, both B and not D. You know, let me just kind of, sorry, I need to slide this to the left a little because I don't want to be leaning too far, so. So yeah, and then the third is if D, then not B. Okay, so in this case, what's the main connective? Well, there's only one connective at all, so it's easy. In this case, what's the main connective? In the second sentence here? Which symbol shall I draw the arrow above? Yes, good, double arrow. The other connectives on this are, you know, locked away inside the parentheses. So you always go to the outermost connective, and that's this one. Okay, and then over here on the right side, what's the main connective of that? It is the arrow, right? The arrow connects the left and the right side. This thing is only attached to the right side, so the thing that connects everything is the main connective, and there we have our 3. Okay, so up here on the top left, we always have to list our letters alphabetically. In this case, what would those be? It's not ABC, Evelyn. Sorry to say that. But there's definitely letters. Yes, it's okay. B and D. Not to worry. Okay, so B, D. B, D. All right, now following underneath the 2 letters. We have the truth value assignments. And then we just go to work plugging them in every case where there is a letter. So T, T, F, F, T, F, T, F, T, T, F, F right here. Okay, so this one's pretty easy, so we'll just start with that. Blank, 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 blank. What is that? It's all good. Yes, not to worry, everyone there. But back to this. So F, F, T, T. Yes, correct. Okay, that's done. Next, let's get this one all out of the way. Starting with the tilde to the left of D. This should show blank, 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 blank. If you're following the pattern, you see that it's FT, correct. Okay, now, for this conjunction, we've got to examine underneath B and underneath tilde. The rule of conjunction is only with two T's is it true. So now, in this column, as we go down, what's the four blanks to add? F, T, F, F. Good. Okay, so now as we finish this one up, we simply have to look on the left underneath D and to the right underneath the caret sign. It's a double arrow, so they would have to match for it to be true. So then 1, 2, 3, 4, what are those four values? Okay, Jessica, you say F, 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 T. T, F, 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 T, F, T, F, F, and then F, F, that's a match. So there we go, F, F, T. So next and finally, we got to complete this part of the truth table, starting with the tilde here on the right, F, F, T, T. And then the last thing is this. We have an arrow, that's a conditional sign. On the left is underneath D, on the right is underneath tilde, and basically only one combination leaves a false value here, but the other 3 out of 4 possible combinations, we would write T. So what can it be here in these 4 spaces, starting with the top? So F, good, T to F, that's false, but nowhere else is there a T to F, so it's false with 3 truths. Okay, so now, let's see if you remember the procedure that happens next. The table itself has been completed, but we've been asked the question, are the set of sentences consistent? So what do we circle now in order to get to our answer? Something or things must be circled, and then we can take another step after that. But let me ask you that question. What shall I circle, if anything, on this table? Where and what has to be now encircled so that we can conduct our, we'll complete this translation exercise. Each column where there's a main connective. Okay, very good, Jessica. So in particular, you're telling me where the 3 arrows are. Circle underneath those 3 columns. Good. 1, 2, 3. So what am I now looking for to answer the question? The question is about whether they're all consistent. I'm looking for what now to answer this question? If they're consistent, what shall I see? If they're not consistent, what other thing would I see visually right now? What does consistency mean in terms of like the visual of this table? If they're consistent, what can be found on the table? Let's not forget these little rules. Okay, so Jessica, you say a set of all T or F in a row. No, that is not correct. So we must try again. That's, well, wait, maybe I'm wrong. Well, yeah, I'm not wrong. It's not anything to do with F, so that's a hint for you. But you're kind of close with the remaining part of what you've said. So let's try and say this one last, or maybe we'll need more than one time, but let's try again. Evelyn, you're saying to me the last row. Fair enough, but I want this to be stated in terms of what you are looking for. So, also loveth, no. Evelyn There we go. Has all t's. So one thing is important, guys. You have to fundamentally know what you're looking for, because if not, you'll never actually have the correct answer. Okay, so what you're looking for is a horizontal row where all of these sentences are true. Okay? You're looking for a horizontal row where they are all true. Yes, the row must have all T. It's not about having all F, though. If one row in each of these three columns is like T, 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 then that means that they are all what? That the sentences are what? If you see such a row where all of the main connectives display the letter T, then that means they cannot all be true, and that means they are inconsistent. So again, then, are these sentences consistent or not? I ask you, are the sentences consistent? Yes or no? Jamie, come on. Yes, they are. Why? Because of which row that I will then circle? Row 4, the last row. Okay, so let's not guess. Like, don't guess. Be like, I think, I don't know, I'm guessing. No, it's not a guess. It's just shown. T, T, T. There's a row where they're all true. That means they are consistent, okay? So these sentences are consistent. Why? Because when the table was complete, there was a horizontal row in all three sentences where the main connective is true in every case. That's the fourth row. True, true, true. It's not the third row because this one's false. It's not the second row because both of these two are false in that row. It's not the first row because they're all false in that row. But there's one row here where they're all true. That means that these are consistent sentences taken together as a set. All right, so that's our answer here for the problem number 5. Let me erase that. Okay, so we're doing the next one now. Oh, false on the last row. Yeah, so no problem. Easy correction. Next up, question 6. Okay, sorry, no, 7, thanks. Question 7 has been stated as follows. It's asking you to construct a shortened table that shows that this argument is not valid, that it's invalid. Okay, so table to examine validity. You know what, I don't need it to be so big actually, because this is a shortened table. How many rows will the shortened table have? Question for everyone. Just one. Okay, good. So let's put the sentences in the argument in the given order up here. So the first premise is A or not B and C. The second sentence is if B, then not A. And then the third, well, okay, so the third sentence is the conclusion. This horizontal line divides the premises from the conclusion. So the sentence at bottom, tilde, tilde B, is the conclusion of the argument. Okay, so now, top left, we have to put down the sentence letters in the alphabetic order. This case is pretty straightforward. What are the letters in the order? A, B, C. Question about the 3 main connectives. What is the main connective of this one? Of the first sentence on the left. It's the wedge, right? What's the main connective of the second sentence in the middle? The then arrow, correct. And then in the third sentence, what is the main connective? You say tilde, but we must be precise because there's 2 of them. Which one? The first one, yes, the leftmost. Okay, correct. So how is a shortened truth table going to work in this case? Okay, so when you make a truth table and you're studying this question, is an argument valid or is it invalid? What combination of truth values would show that the argument is invalid? Correct, Loveth. If you have premises all being true and conclusion false, that would be the scenario where the argument would not be valid. If there's even one row in the table where the premises are true and the conclusion is false. So this is a shortened table. That means that we're going to work backwards from the assumption that this is the row where the premises are both true and the conclusion is false. So what letter shall I write right here underneath the wedge? Just to make sure you understand this point that I'm making. Underneath this wedge, I will write T. That's right. Underneath this arrow, I will write what? T. And underneath this left double negation, I will write F. Okay, very good. So now we simply work backwards from the supposition that these are the truth values of the three main connectives. Start over here because this is the least complex. If tilde B is false, then what's the value of its tilde just to the right of the double tilde? The right-hand tilde shall say truth value what? T, good. Which means that if tilde B is true, what's the value of B itself? False, correct. So, sorry, oops, my bad. Not FTB, please do not write that in your notes. Simple little error in writing. F, thank you. Not B is the same statement as B. So not B always has the same truth value that B has. Like for example, let's see. Like, okay, say Biden won is true. Biden didn't win is false. Biden did not win is also true because not winning is the same thing as winning, right? So like not winning is losing. And therefore, not the case that you didn't win is that you just did. Okay, so like you can imagine B stands for Biden won. Well, I guess if it's F, then it would be like Biden lost, which is false. Not the case that he lost, true. Not the case that he didn't lose, false again. But anyway, just reminding you about the way that double negation works. Right now you're watching a lecture, true. It's also true that you're not watching the lecture. So, I mean, it's a more complex way of saying the same thing. We probably don't normally talk that way, but sometimes we do. I've heard it said in pop culture, like, you know, someone's like, well, he's not wrong, you know, is a kind of backhanded way of saying he's correct. Like, if you're not wrong, being wrong is like saying not right. So if you're not right, then you are correct, you know. So anyways, back to this. We now know what about B? Well, that it's been given the truth value F. So wherever we see the letter B then, we place that truth value underneath it. And that gives us more information as to how we continue. So here we see a conditional. This conditional starts with a false antecedent. So what truth value would you like to assign to the letter A? Let me know about that. New question. So we've got to decide on what value to give A. And you can just tell me which one you want. There's two options, so just, you know, whichever one. Okay, Jamie, you suggest T. So let's do that. Here, A is true. If A is true, then what's the value of tilde on the left of A? False, correct. Go with capitals, though, because it's not so easy to sometimes see, Jamie, the lowercase t's and f's on the screen. But then this would be F, okay? And that's fine, because F going to F when it's the conditional connective, that's a true conditional. All right, so over here now, this is a disjunction. The left disjunct is true, so it's already going to work out, but we still have to finish the remaining blank spaces here. What's the value here under this tilde to the left of B? T. Now, this is a conjunction, and it really doesn't even matter what the value of C is going to be, because if C is true, this is a true disjunction, and even if it's false, same. So whatever, what do you think? What shall I decide for C's truth value to be? T? Okay, good. So C, let's say, is true. In that case, what's the value of the conjunction here? The conjunction right there. Also true, because on its left is a true tilde B, on its right is a true letter C. So true, true, that's a true conjunction. So now, look at this. True, true, false. We did it. A shortened truth table that shows that this argument is not valid. And that's all it is. It's an argument, but it's not a valid argument because there are multiple rows actually in the full table where the conclusion could be false and the premises could be true. Again, I would remind you, if an argument is valid, that means by definition that it is not possible for all the premises to be true and the conclusion false. But in this case of an argument, it is possible for the premises to be true and the conclusion false, as you can clearly see. Therefore, it is invalid. Okay, so that's problem number 7. Let's go on to the number 8 problem then. Okay, so it's problem 8, and it says, is this argument valid? Now, in this case, it does not specify to give a shortened truth table, so let's just try and make a full truth table. Okay, so the first sentence is H, if and only if, either K or not J. The second sentence, the second premise, is that if both K and H, then in that case, not J. And then finally, get this line a little bit more lined up. Okay, and so the conclusion of the argument is just not J. All right, so to the top left, we have to list the letters that occur in all those sentences. By the way, main connective, main connective, main connective, 3 of those. All right, so alphabetical order of the 3 letters here. What should that be? 3 capitalized letters, H, J, K, correct. Well, with H, J, K, 3 sentence letters, how many rows have to be created in this table? 8. Good. So when there are 8 rows needed, we look at the leftmost column where it says H. And the rule is that the leftmost column, wherever it begins, and however many rows it is going to take, the top block are going to be all T's and the bottom block are going to be all F's. So 8 means 4 by 4. T, 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 F, 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 F. Underneath J, the alternation rate just doubles in frequency, so it's 2 by 2. T, T, F, F. T, T, F, F. And then finally, the single alternating last column, which is always like that. Sorry. Oops. All right. So the next part of the truth table is just kind of like automatic. It's a little mindless. You just simply copy the vertical display shown under each letter the same way it is here. So wherever there's H, that's how we write it. Wherever there's K, it's going to be that single alternating pattern. Wherever it's J, it's the double. And likewise in these other cases, okay? So T, F, T, F, T, F, T, F, T, 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 F, 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 F. And then finally J, these last 2 are the 2 by 2 cases. Okay, so now we get to, the connectives. Perhaps this will be the easiest one. What's the row of 8 that should be shown under this tilde here, starting from the top, going all the way through down to the bottom? In order of T's and F's, we should see what in that column. Okay, yeah, so starting with F double FFTT pattern. Okay, so that's one completed part of the truth table for the conclusion. But we still have the remaining parts. So this is tilde j, the consequent of this conditional. And so this column, anyway, will mirror that one. And we save this arrow for the last column of this using the rules for conjunctions. What are these 8? 1, 2, 3, 4, 5, 6, 7, 8. 8 truth values in that conjunction spot. What will those be? Once you have it, put it in the chat, and then I'll add it to the board. Just let me know. 8 letters. Okay, so Lily, you're giving me T, F, T, and then all F's. T, F, another T, and then remaining are all false. Yes, why? Well, it's because for a conjunction, what's the rule? It has to be that both conjuncts are true. But that's only seen on the first row and in the third. In all other cases, there's an F somewhere on the left or right. Okay. So now, for this conditional column, we have to compare what's written underneath the conjunction sign, this column, with what's written under the tilde of that column. Those two things will generate the value of the empty space. So now, I need to know the 8 truth values that are associated with the conditional. Those 8. What are those? Anybody could tell me. Let us remember the rule for conditional. When is a conditional false? When you have what combination of truth values among the antecedent and consequent? Question for you. When is a conditional false? Just tell me that. When it is TF. Yes. So to be very precise, when the antecedent, the left side, is true, and the consequent, the right side, is false, that's when it would be a false conditional. So now, using that information, tell me, please, what are these 8 truth values to be writing? So, Brenna, you say F, 3 T's, and then FT. Let's see. So this is fine. TF, that is false. T. Another T. Okay, true again. Also still true. Now, did you get that? No, because you thought that the fourth one, your answer is incorrect because you're saying FTTTF. This is true also, though. It's false leading to false, which is not T to F. So this is still true. Also in this case, true. Here, true, and finally in the bottom, true. So this is the display scene. So yeah, Brenna, it's like false and then everything else T. So it's not correct, your information about column 7 and column, what would that be, 5. Yeah, so understand, right? Yeah, not to worry, but just make sure that's like totally drilled in your mind because it shouldn't be guesswork. There's just rules. The rules, they never change. So when you have a conditional, you just need to know if I see T and F on the left and right, that's when I write F. Otherwise, it's true. So you only have that combination in the first horizontal row. Okay, good. So now we're looking at this part. We're going to do the double arrow last. So let's work on the interior of this parentheses. Okay, so tilde j is the right disjunct in this little subsentential expression. That means we're going to see the same ordering to the left of j that we have in these other two cases. So F, F, T, T, F, F, T, T. Now this is a disjunction, okay? Let's first of all clarify, what's the rule of a disjunction? How many components of it would have to be true for the disjunction to be true? At least one. Yes, and it could be on either side. So if either of the two sides are true, then true is what gets written here. So 8 values now have to be added. Tell me what these 8 should be based on the logic of disjunction and the existing truth values that are displayed. What should these 8 things say? So you're looking at K and tilde on the left and right to generate the value. And again, if you see T, let's hear it. What are these 8 truth values, starting on the top and then proceeding all the way down the column? Okay, Ruby, you say T, F, and then only one more F, which is the 6th one, yes, and everything else true. Okay, good. So notice, why were these 2nd row and 6th row the ones where we write F? Well, because on the left and right on those 2 cases, it's FF. In all the other cases, it's either both T's or one or the other, and that's enough for this to be true. Okay, so finally, we've reached the end almost. Here's a double arrow. Double arrows are biconditional, so we must then compare what's written underneath H on the left with whatever's written underneath the wedge to the right. Question again, what is the rule for the double arrow? What truth values have to be shown on the left and right for it to receive the assignment that it's true? What combination of values to the left and right must be present for the letter T to appear underneath the main connective? That's my question to you. What combination of values? Okay, good, Lily. They must both be matching. So like a matching pair of socks, they have to be the same. They must both say T or they must both say F. But if they don't have the same letter on the left and right, then that would be false for biconditional. Okay, so that tells you something. So left underneath H and to the right underneath the wedge. And you're looking basically for a matching pair. So 8 values then. 1, 2, 3, 4, 5, 6, 7, 8. What will they show in those 8 cases? Based on the information about the rule for biconditional and the values shown on the board. Just to fill in these 8 blank spaces, they should say what letters. Go ahead, take a moment if you need it, but please do let me know what truth values shall be shown here. Think actively. Don't merely wait for other students to answer so that you can then copy the information and then think about it at some future time. Think about it now because we're together now. And when you're by yourself, I don't think you're going to want to spend too much time thinking about logic on your everyday routine. So like when we're in class, that's the most high impact time for you to get some value out of the course material. Yeah, so good, Evelyn. You say T, F, T, T, F, T, F, F. Now, is that what you have there? It's T, F, double T, F, T, F, F. Yeah, good. Okay, so we circle this column. We're one step away from being done, but we've not yet finished because the question remains, is this a valid argument or is it not valid? So I ask you, now that the table's complete and all the relevant columns are circled, you're in a position to look at this board and say, is it a valid argument or is it not? So let me know if it is or not. It can't be both. It's one or the other. Which one is it? Valid or not valid? Okay, I'm seeing some say invalid. Good. If it's invalid, why? Which column shows this? Or columns, if that's the case. Which column? No, I don't mean column, sorry. Which horizontal row, thank you, is the row or rows that display invalidity? Good, Valeria, and Arlene and Lily. It is the 6th row. So we must now circle that cross section to show this visually. Why is this the row? Well, because look, T, T, F. Those 3 values are shown in the 6th row of the truth table. Since there is a row where the premises are true and the conclusion is false, that means that this argument is an invalid argument. If there's an invalid argument, one or more of the rows show the premises being true and the conclusion being false. So that's what you have to sort of scan for visually when you complete these truth tables that ask about the status of an argument, whether it's valid or not. You finish out the truth table, and then you simply look at the premises compared to the conclusion in every single row, one by one. And you're looking for the display T, T, and then on the right hand, F. If you don't see any such case, then you would say it's valid because there's no row to circle then. If there is a row to circle, that indicates that it's an invalid argument. You circle that row and you write that. Now, when this table was finished, you could have reasoned in the following way. It's only invalid if I find some row where the conclusion is false and all the premises are true. So you could simply look over here, and if you see there's four cases where the conclusion is false. So you can reason backwards from that. These four are the only ones that even have a chance to be the ones where it shows that it's invalid, right? Because when the conclusion is true, that does not apply to the case of invalidity. So we would look at like line 1, row 1, and then we would sort of go to the left and say, are the other premises both true? No. In this case, one of the premises is also false. So it doesn't say TTF. So that one's not it. So we move on. Second row, okay, conclusion is false. Are the premises both true? Well, now the second one is, but the first one is false. So we still don't have TTF. Okay, we can skip these two because the conclusion isn't even false. Here's the fifth row. Okay, conclusion false, fine. Second premise true, but once again, the first premise is not also true. And so that's not a situation where the premises are true and the conclusion is false. And then finally, our eyes turn to the sixth row. And here we do see that combination. False, both premises are true. That's the one to circle. That means that the argument is invalid. Okay, so that's just our answer for our question number 8. And then there's just 2 more questions here, so I want to be complete, and I want us to cover all of them right now. So let me go over number 9. Okay, so question 9 is an argument, and we have to first of all translate this argument using our symbols and sentence letters. So let's try and get that part out of the way. Tell me about some letters that I should use to convert this English stuff into logic. And I'll just write it once it's there in the chat, once you give me something to write. So we are all looking at question 9. Okay, good, Arlene. C. Carol will go to the store. That looks good. B. Bill will go to the store. All right, Bill will go to the store. A. Al will go to the store. And I think that's all that we need in terms of letters. Okay, so this is an argument. There are 2 premises and a conclusion. So there's 3 full sentences that we must translate first of all. What's the first premise of the argument in terms of logical symbols? Where it says Carol won't go to the store. That should be written in logic as tilde C. Okay, good. And then the second premise is that Bill will go only if Carol will. How do we say Bill will go only if Carol will go? Bill will go only if Carol will. So that's the next one. One second, I'll be right back. I dropped my pen cap. We know this, right? The second sentence. Please just inform me. What will it say? Question, are you Having trouble typing? Is there something wrong? Let's see here. Oops, no, I meant to send that to the whole group. Oh, okay, good, there it is. For a minute there, I thought you guys had dropped out. Okay, so Lily, you're saying, and Arlene also, B, arrow, C. But everybody, come on, everybody start answering these questions. You're leaving a lot of the heavy lifting to just a few people. You're a participant of the class too, so you got to really get this going, all right? B, arrow, C. So then the third premise, there's three premises and then the conclusion. So we still have another premise to go. It says neither Al nor Bill will go to the store. How do you say this? Okay, tilde, parentheses, A or B. Yes. Not either A or B. And then finally the conclusion is Al will go if, but only if, Carol does. And what's the status of that one? How does that get captured in logic? Al will go to the store if, but only if Carol does. Okay, A, double arrow, C. Okay, so that premise, and then the conclusion. I'm going to rewrite this, though, so that I can actually create the full table, because I made it a little bit too far over to the right. But these are the sentence letters. Those are the statements involved. So now I'll just simply rewrite those in a little bit of a more clean format. So what we have is tilde C, B, arrow, C, not either B or, wait, sorry, let me get that third one, not either A or B. And then finally, the last thing, A, double arrow, C. Okay, so how many sentence letters are there? 3. So this requires a total of 8 rows. Now, the alphabetic order, that's easy, A, B, C. What are the main connectives? Well, in this case, there's only one connective, so there's no debating it. In this case, also, there's just the arrow. What's the main connective in the third sentence, the third premise? That's my question now. Tilde, correct. Because it's outside parentheses, so that's why it is the main connective. And then over here, it's the double arrow, the only connective shown. Okay, so we need 8 rows, and then we'll simply do that according to the same algorithmic procedure that we always do. See, I mean, I'm sure you agree. I don't know if you actually do. Everyone's a little different, but I believe that translation is just way easier than doing proofs because it's kind of just mindless. I mean, you don't have to think, how do I infer anything? You simply apply rules, and the rules are just given, and they can't be changed. So, you know, once you know how to do it, it's just, it's like every truth table is kind of the same in a way. Okay, so we're now going to fill underneath C with this vertical display of TF, TF. There's a tilde on the left, so it just reverses the order. Okay, B is the TTFF column. C, again, is the single one. Okay, when we have A shown on the truth table, it's 4 by 4. B is again 2 by 2. Okay. Okay, so the arrow, 8 blank spaces, 8 truth values. We all should know that it will only say F if on the left there's a T and on the right there is F. So, you know, where you see TF, that would be an F row. Everything else is T. So what do you say are these 8 values starting at the top? Good, Tanya. So it's false when there's a T and F, so I guess it's only in the case of the second and the sixth row where you would write F. So it's T in all the other cases. Perfect, yes. Okay, so I mean, this is one of the columns to circle. We already did that. And this is another one because it's under an arrow. Now we're working on this third one. Saving this for last because it's the main connective. So here we have the wedge in between A and B. Disjunction means write tilde A or B in the table as, no, that is not okay because it's not the same sentence. What you could have written would be not A and not B. Okay, so let's make sure this is something you remember. This sentence here, or here I'll put it in the chat. So, look at what I wrote in the chat. Can you see that? This is something that keeps coming up. Tilde parentheses A or B is not the same thing as tilde A or tilde B. It is the same thing as tilde A and tilde B. Okay, so these two things here are what are equivalent. So had you written this, that would have been a fine substitution. But as it's written in your own sentence there, it's wrong. So yeah, that would be incorrect. Because that says either not A or not B. Okay, so like for example, right now, either Trump will not win or Biden will not win. That's not the same thing as saying neither one will win, right? To say neither will win would be like maybe they both get assassinated before election day, and in that case, neither one will be the next president. But to say either Trump will not be the next president or Biden will not be the next president is disjoining the two negations. It's not negating the disjunction itself. Okay, so just think about what I'm saying here. And that's the reason I had to correct that. But okay, back to this. Underneath this or sign, we have to have 8 truth values. So where is there a T and where is there an F in this column of 8? Starting at the top, going down. There only just has, no problem. There just has to be one T somewhere on the left or the right for this to say T. So you have 8 things. Tell me, please, what are the 8 things going in the order from top to bottom? Yes, thank you, Ruby. Okay, so true all the way down until we get to these 2. Perfect, right. Now, the tilde. The tilde outside of the expression is negating the disjunction symbol's truth value. So whatever this is, under the tilde, it's going to be the other thing. So now I want to know 8 truth values underneath the tilde symbol. What are those going to say? Okay, and good, Evelyn. It's just the reverse order as what was mentioned just now by Ruby. So it's a bunch of F's with 2 T's at the bottom. Okay, so now we come to the end, the conclusion. This is a biconditional. You know the rule, I hope. It's that if it's both T, then it's true. If it's both F, then it's true. But if they don't match, then it's false. So go ahead. What are those 8 truth values then in the right order from top to bottom? So T, F, T, F, F, T, F, T. Good. True because TT, false because T, that's not, this doesn't match. True because they're both the same, false because they're not the same, so false. Both are false, so that's true. They have matching Fs, and in this case they don't match, but in the final row they also match with 2 Fs. Okay, so it's an argument. It's been fully translated. The truth table's been constructed for it, and now we still have to answer this last question. Is the argument valid or is it not valid? So tell me that. Is this a valid argument, or is it just not? You're saying, Lily, that it's valid. Okay, good, because as we look through it, we would, if it was not valid, we would be able to see a row where all the premises are true and the conclusion is false. So let's see, starting with any row where the conclusion is false. Okay, in the second row, the conclusion is false. Let's see the premises. Well, they're not all true, so that's not the one to circle. Here's a fourth row where the conclusion is false. But again, the premises are not all true, namely the third one, so that's not the one to circle. Here is the fifth row. The conclusion is false, but looking at the other sentences, they're not all true, so we can't circle that one. Last is the seventh row. Conclusion, false. Premise 3, premise 2, both true, but premise 1 is false, so we don't have every premise being true and the conclusion is false. So there's nothing that we can circle. That means that it's not possible with this argument for the premises to be true and the conclusion false. In other words, the argument is valid. All right, so that would be the answer of question number 9. Finally, we reach the 10th and last question of the homework. Okay, so question 10 is a single sentence, one sentence, and it's just asking its status. Is it logically true, logically false, or logically indeterminate? So it's kind of a big beast of a sentence, but what you have here is A, if and only if B. Oh, sorry. So if and only if B, then in that case, either if B then A, or not A. And the whole thing is negated. Okay, so this is like saying it is not the case that if A, if and only if B, then either if B then A or not A. Okay, so the negation is negating the entire big sentence here. Then this is the main connective. Okay. So although it's a big sentence, there are only 2 sentence letters in it. So that means there's only 4 rows that are needed. Under A, we write TTFF. Under B, we write TFTF. Okay. Yeah, so like 1, 2, 3, 4. 1, 2, 3, 4. Yeah. Now, underneath every occurrence of A, we simply reproduce the truth values given in each assignment. Okay, so let's see where we should go first. I mean, here we have a little parenthetical expression that we can just finish. So it's double arrow. What's the value here? Row 1. Just quickly let me know if you can. Row 1, truth value T. Row 2, F. 3, also F. And then finally, the 4th row down here, true. Good. Okay, that's completed. Let's get over here and do this little internal parentheses of B then A. So, you know, T leads to T, that's what? Row 1, true. False leads to true, and that's true also. True leads to false, row 3, false. And then finally in the 4th row, false leading to false is true. Okay, now, this is tilde A. So this tilde is easy enough. It's simply going to be negating these 4 things. So that'll say FFTT. Now, here's the wedge symbol. The wedge symbol is going to compare what's underneath the arrow on this side and what's underneath the tilde on this side. And since it's wedge, all you need is to have 1 T on either side. So row 1, what will that be? And yeah, Evelyn, just letting me know, they're all T's. T, 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 T. In the top 2 rows, it's because of the left disjunct. On the bottom 2 rows, well, it's, in this case, it's because of the right disjunct, and on the bottom row, both are true. Okay, so a little more work still. Next up, we have to complete this column underneath the arrow. by comparing the double arrow to the wedge. So T to T, true. F, well, when there's a false antecedent, that's already known as a true conditional. So same here. And then in the fourth, true leading to true, so that's also true. Now what is this negation flipping? This negation is going to negate what column? Or, yes. The negation flips this column, where this is the internal main connective of the parenthetical expression. So what should these four things be on the left? Underneath the tilde, blank, 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 blank. F, 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 F. We circle here. Now we can answer. Is the sentence logically true, logically false, or is it indeterminate? It is logically false. Okay, so that would be the full corrected information for the whole homework number 3. I'm going to also double this by sending a answer key to the students here. And I'm done pretty much with all the grading of this as of either later tonight or tomorrow morning. So I'm going to send off the next homework problem set, the answer key for this, and then of course any student who's curious about checking their score for this or for anything else, as I've done throughout the semester, I'll just invite you to send me a message, and if you want, I can tell you any of those scores and let you know where you're standing. So the fourth homework is really just all about derivations for the most part. So the kind of stuff, that, not that we did today because we were reviewing and showing homework 3, but the stuff that we've been doing for the past couple of weeks where we're doing inferences and trying to derive a result. That's going to be the bulk of homework 4. And we will be able to work on it for a couple of weeks because it's not due to me until, let's see here, just pulling up my, sorry, I gotta slide it over here. Why would the tilde be the main connective? Okay, a question has been asked to me in private about why is the tilde the main connective? Because it's outside of the entire expression that's in brackets. Ask yourself, what is this tilde negating? What is this tilde negating? It's negating not A, because it's not on the left of A. It's not negating the double arrow, because it's not on the left of this parentheses. It's not negating B, because B is enclosed within these parentheses. Okay, so this tilde can't possibly be acting on any part of this expression, nor can it be acting on any of this stuff over here, because this is all the consequent of a big conditional. So if this tilde was not like there, and these outermost brackets weren't there, this whole thing would simply be a conditional. It would say, if A, if and only if B, then either if B then A, or not A. But the tilde, though, it's negating everything contained within brackets. And everything contained within brackets is this entire formula. So you see a tilde can't just be floating there for no reason. It's operating on a sentence that it's attached to. Therefore, since it's attached to this whole sentence and not just like one part of it or another part of it, this main connective of the full sentence is what the outer tilde is reversing. Okay? But yeah, to the homework, I was just going to tell you that the official due date is listed here as December the 2nd. I'm thinking of even moving it out until the 7th to give you 5 more days to complete it. So then in that case, you'll get a little bit more additional time and we'll have more time to do practice. But yeah, I'm still going to distribute it overnight. So be ready for that. And I'll also let you know you can check on the scores of the other stuff. Okay, now Wednesday, hopefully you know this. It's a holiday. It's Veterans Day. So we will not meet until next week, a week from today. But in the meantime, as always, please check in with me if you need anything. Come to the office hours if you'd like any other help. I won't hold my Wednesday office hours because it is a holiday, but I'm happy to arrange any other times for people if they want. So, okay, guys, sorry to hold you for an extra minute, but let's break for now. Have a great day. Hope you had a good weekend. And I'm going to stop the screen share, and then I'm going to close both meetings. Okay, then? So here, this one is ending, and I'm going to end the YouTube one next. So thanks. And here we go. All right, YouTube. I'll see you guys back next week. Be in touch, and take care.